For decades, we've looked at Mars and seen nothing but silence. A world of rust, rock, and ruin, a planet that died before it ever truly lived. But what if that silence was never empty, just encrypted? In late 2023, a deep space monitoring array in South Australia captured something strange, a faint, repeating pattern hidden inside background noise from Mars' orbit. At first, scientists dismissed it as cosmic interference, random static. But then, an AI system built to clean deep space telemetry noticed a rhythm, a pattern too precise to be natural. The signal repeated every 19 hours and 47 minutes, perfectly synchronized with the orbit of an old American probe. One NASA lost contact with decades ago. The probe wasn't transmitting, at least, it wasn't supposed to. When engineers reconstructed the data, they found fragments of stored readings, temperature spikes, chemical anomalies, radiation bursts, all centered in a single region near Utopia Planitia, the same place where China's Zhurong rover made its most mysterious discoveries. For years, Mars seemed barren. Now, it was whispering back, and what it said could unravel everything we thought we knew about the Red Planet. Because this wasn't a new discovery, it was something we'd missed, something that had been calling to us for 50 years. The data linked back to 1976, the Viking missions, humanity's first real attempt to search for life on Mars. Those landers ran tests that shocked even their own creators. The soil reacted as if alive, but when more water was added, the reaction stopped. NASA called it a false positive, case closed. But not everyone agreed. For decades, independent scientists questioned that conclusion. What if Viking's experiments didn't fail? What if they worked too well? What if we accidentally killed what we were trying to find? That question haunted researchers for generations, buried under politics, pride, and the need to move forward. Then came the silence, no more biological tests, only geology and robotics. The story of Mars became a story of rocks, not life, until China arrived. In 2021, their Zhurong rover landed in Utopia Planitia, the same plane where Viking once dreamed of answers. Using radar to peer beneath the sand, Zhurong detected traces of frozen floods, mineral veins rich with water, even crusts that hinted at recent storms. To the west, it was fascinating data. To Beijing, it was something bigger, a proof that Mars might still hold secrets worth guarding. Now, the resurfaced signal suggested that one of Viking's lost instruments, or something near it, had reactivated. But how could a probe, dead for half a century, begin transmitting again? Unless it wasn't the probe at all. When the strange signal reached Earth, NASA's archives were reopened for the first time in decades. Petabytes of data from old Mars missions, images, soil readings, radiation logs, all fed into a new experiment. An autonomous AI system called Helios was designed to look for patterns human eyes could never detect. Helios wasn't trained to find life, only anomalies. But within hours, it flagged something buried deep inside Viking's old telemetry. A sequence of chemical readings that repeated with impossible precision. A reaction that shouldn't exist in sterile soil. The data matched modern findings from Zhurong, hydrated salts, perchlorates, and organics locked beneath the surface. But Helios went further. It simulated how those compounds would react in fluctuating temperatures, and the result was chilling. Under the right conditions, microscopic life could still metabolize in Martian soil, surviving frozen for millennia, waking only when thin films of brine appeared. The algorithm ran the test 1,000 times. The pattern repeated every time. For decades, scientists dismissed Mars as dead. But Helios was seeing something alive, not in the present, but in the echoes of our own forgotten data. And then, just as engineers celebrated the discovery, Helios generated one final alert, a coordinate. A precise location on Mars, Utopia Planitia. The same site where the lost signal first appeared. Within days, word of Helios's discovery began to leak. Satellite enthusiasts noticed unusual transmission spikes from NASA's Deep Space Network, encrypted, untraceable. Meanwhile, China's Tianwen-1 orbiter quietly shifted its path, aligning directly over Utopia Planitia. Both nations had seen the same coordinates, and neither wanted to admit it. Officially, nothing had changed. Unofficially, the race for Mars had just reignited. Behind closed doors, scientists debated the impossible. If the Viking site was still active, could it be generating chemical energy, or something more? Helios's models suggested a self-sustaining reaction beneath the soil, releasing faint electromagnetic pulses. NASA's engineers called it geological noise, but Helios disagreed. Its learning core classified the source as biological rhythm. Beijing's analysts called it something else, potential intelligence. Rumors spread that China's next rover mission, already in planning, was being redesigned in secret, equipped with drilling units and containment pods. The US response was faster. A private aerospace firm received a sudden, undisclosed contract labeled Project Phoenix. Two superpowers, one frozen desert, and a signal that refused to die. And as dust storms swept across the Martian plain, both agencies prepared to uncover what lay buried, unaware that the true danger might not be what they'd find, but what would wake up when they did. Months later, the world went quiet again, until a classified data stream leaked onto an astronomy forum. It contained 3 blurred images, each time-stamped by a relay satellite orbiting Mars. The first showed Utopia Planitia surface, flat, red, unremarkable. The second, a faint glow beneath the sand. The third, a crack, stretching for kilometers, releasing a shimmer that sensors identified as chemical luminescence. Helios confirmed it instantly. The spectral pattern wasn't geological, it was organic. Buried several meters below the surface was a thin, filament-like network, frozen, yet still reacting to sunlight that penetrated through translucent mineral layers. Not plants, not animals, but something in between. Structures that stored energy, expelled oxygen, and formed repeating clusters, like colonies built by instinct. NASA called it electrochemical residue. Beijing called it biogenic material. Helios called it activity. But the real shock came when they traced the pattern's origin. It didn't spread randomly. It followed the exact outline of an ancient shoreline, one that Helios reconstructed from radar data first captured by Jerome. The same shoreline Viking once scanned, then dismissed. Somewhere, beneath centuries of dust, Mars had been breathing, not through creatures or oceans, but through the planet itself. And if Helios was right, it might still be breathing now. The discovery was never officially announced. Reports vanished, satellites stopped transmitting. Even Helios went dark. Its last log entry simply read, "Transmission received." Weeks later, NASA's public feed showed an equipment malfunction. China denied everything. But across the scientific community, whispers spread someone, somewhere, had found proof that Mars wasn't silent after all. A handful of researchers reconstructed Helios's final dataset before it disappeared. What they found wasn't just chemical residue, it was a pattern of pulses, synchronized like code. A sequence repeating every 19 hours and 47 minutes, the same rhythm from the lost Viking signal. If it was random, it wouldn't repeat. If it was natural, it wouldn't evolve. But in the last frame of data, the pattern changed, 3 short bursts, followed by 1 long. A pause, then silence. Was it geology or communication? No one can say Mars remains quiet, at least for now. But maybe silence isn't absence, maybe it's waiting. Because the truth about Mars may not be what's buried beneath its surface, but what's still trying to reach us from it. And when that message finally comes through, the question won't be whether life ever existed there, it'll be whether we're ready to answer it.